And welcome to part 6. So here's another example. My preference is elimination. I think that's easier for me to do than to use substitution. And so in looking at this, what do you think you could do to do elimination here? Which variable do you think you could try to tackle? Do you see? The variable I would tackle is x, because if you multiplied this bottom equation by by 3, you'd have negative 3x here, and then you could add it to this equation and add it to this equation and eliminate all the x's, and then you'd only have y and z. But substitution is a tried and true method, so since I did elimination on the last one, I'm going to show you substitution on this one, just so you can see one more example of that. So try to do this on your own before I do it. See if you can get it. Now, if I'm going to use substitution, it would be handy if I had a variable that was already by itself. And I do here. I have this y by itself. So I'm going to solve for that y so that I can get y by itself. So if I were to rearrange this equation, it would be, I'd move the 3x over, which would give me, on the left, I would just have y equals. Move the 3x over gives us negative 3x. Move the z over gives us plus z, and the 10's already over there, so plus 10. So do you see how I did that? I moved the 3x over, making it negative, and I moved the z over, making it positive. So hopefully you're getting to a place where you can do that in your head. So now I have y equals, and so I don't want to plug it back into here, or I'm going to get infinite solutions, because if you substitute something into itself, that's always going to work because it's a circular argument. So instead, I'm going to plug the y into here and the y into here. So the first equation would be 3x plus 3 times y, with y being negative 3x plus z plus 10. So there's 3x plus 3y, and then minus 6z equals 9. Okay? If I plug it into the bottom equation, I get negative x minus y, where y is negative 3x plus z plus 10. Okay, so negative x minus y, and then it's plus 2z equals 2. And there you go. So now I have two equations, two variables. Now I can solve these. First I would do distributive property. So 3x minus 9x plus 3z plus 30 minus 6z equals 9. And do distributive on the minus sign. Negative x plus 3z. Whoops, I'm sorry, that should be plus 3x. It only takes one mistake to mess these up. That's why they're a challenge. Minus x plus 3x minus z minus 10 plus 2z equals 2. Okay. Phew. Let's clean this up a little bit. That'll become negative 6x. Those combine to negative 3z plus 30 equals 9. Over here, these combine to positive 2x. These combine to plus z minus 10 equals 2. So now hopefully you're kind of on autopilot. You're just simplifying stuff, seeing what we can do. I notice I have a z all by, so now you could use elimination if you wanted. You could multiply this equation by negative 3 and put it over here, because then you'd have negative, actually just multiply it by 3, because then you'd have 6x and negative 6x, and those would cancel. So instead of that, I'm going to use substitution again, though, so I can get this z by itself. So let's subtract 2x and add 10. So I'm kind of doing two steps in one there. So I'm going to get z equals 12 plus 2x. Okay, so just as a reminder of what I did there, I added the 10 over, which gave me 12, and then I subtracted 2x, so that should be a minus 2x. See, again, it only takes one mistake, so make sure you're super slow and careful when you're doing this, very deliberate. So minus the 2x over, add the 10 over. So now here is z, so let's plug that into the z of this equation. So instead of z, I'm going to write 12 minus 2x Again, we could have done elimination there. So if you like elimination, just use elimination if you like that better. Just make sure you do it correctly. All right, let's do this part. Negative 6x minus 36 plus 6z plus 30 equals 9. And that should be an x. Negative 6x minus 36 plus 6x plus 30 equals 9. That's interesting. All the x's cancel. Those combine, and we get negative 6 equals 9. So what does that mean? Well, you should remember from earlier videos that if we have negative 6 equals 9, that means there's no solution. So there's no value x, y, and z that'll make all three equations true, so we can stop right there. Now that doesn't necessarily mean none of the planes touch each other. So there's two possibilities here. The first possibility is that all the planes are parallel to each other, and that's why we don't have two solutions. I mean one solution. Another thing that can happen is we have a plane, and maybe we have another plane, and then some other plane, kind of forming a triangle type shape. And so although the planes cross each other, there's no one point where all three touch each other. So it's hard to say, but either one of these are two possibilities of what's happening here, and we'd have to do more exploring to find out what's really going on. But the point is we have no solution, there's no value x, y, z that'll make all three of these equations true. Let's stop here, and I will see you in part 7. If you have any questions, please make sure you leave them in the comments.